Today's lesson will be on groundwater. Groundwater is water that enters the ground, filling up spaces in soil and sediments. It could even fill up cracks and spaces in the bedrock. Groundwater is usually fresh water and generally free of organic pollution, germs, and dangerous contaminants. If we want to look at the distribution of Earth's water here, 97% of Earth's water is in our oceans, or it's salt water. Only 3% is our fresh water. Of that 3%, 68.7% is glaciers and ice caps, 30% is groundwater, and less than 1% would be our lakes, swamps, and rivers. So today we're going to talk about this 30%, which is groundwater. To understand groundwater, you have to have a good basic understanding of the water cycle. Remember, we talked about this yesterday in our activity, but specifically we're going to talk about infiltration. Now, infiltration is the process of water soaking into the ground under the influence of gravity. I always remember infiltration goes into the ground. So I made a chart here to kind of show the difference between when is water going to infiltrate and when would it run off or flow off of the surface. I would pause your video and fill in your chart and then replay so you can listen to what I'm going to explain. So if your ground is saturated versus unsaturated, we're talking about how much water is in our ground. Well, if it's already saturated, that means it's already filled with water, so it's not going to be able to accept any more. So runoff would occur. If it's unsaturated, water can and it has space to fill in and seep into the ground. Just think about if you've ever overwatered a plant and you see that layer of water at the top of the plant, that's technically runoff because that the soil there is already saturated. If the ground is frozen or not frozen, if it's frozen, it's impermeable, so water will not be able to seep in, so runoff will occur. If it's not frozen, you'll be able to have water seep in there. If precipitation is rain, that rainwater will be able to seep into the ground. If it's snow, we've seen snow pile up, we know that it will not seep into the ground. Slow, gentle rain versus rapid, intense rain. If you've ever watched one of those really strong storms in the summertime where we see that really strong, intense downpour, you tend to see puddles forming on the ground. That's because the ground can't really accept all that water at the same time. So a slow, gentle rain will have more infiltration. Rapid, intense, ground can't accept it. It's going to flow right off. If vegetation's present, we can see infiltration occurring. Area with no vegetation is going to have more runoff. And then the steeper the slope, water doesn't have time to seep into the ground, so it's going to flow right off. Gentle slopes will have more infiltration. So let's take a look at this diagram here. Two things. There's a zone of aeration and a zone of saturation. The zone of aeration, just think about air, okay? This is when our bedrock or our rock is filled with air. There's really no water in it. The zone of saturation is below that, and that's where water is filled into those empty pore spaces of our rock. So saturated, think about water. Aeration is air. The water table is the upper limit of this zone of saturation, and the water table is the level of the groundwater within our ground. So the height of the water table will depend upon how much infiltration is in the area, the horizontal flow of groundwater, and also the usage. If you look here at well A and B, A is using way more water, that's why their water table is lower. B isn't using as much water, their water table is higher. Climate does affect the water table. More humid climate is going to obviously have more infiltration into the ground, which is going to increase the height of the water table. A good way to tell how high your water table is the height of a stream or a creek in the area. That is the height of the water table. An arid region, obviously more dry, water table is going to be lower, and you have more of a chance for your streams to dry up because the water table is so low. Now there are some factors that are going to affect the movement of groundwater, and this is really the core of our lesson for today. The water really depends upon the porosity and permeability of the ground. So permeability is the rate at which liquids pass through pore spaces in rocks and soils. Porosity is the percent of a material's volume that is pore space. So we're going to start by talking about permeability. Permeability, again, is the rate at which water or other liquids pass through pore spaces of a rock. So we want to know how much water and how fast that water can get through the rock itself. Large size particles are going to be a lot better. So if you have a sand, a gravel, a pebble, you can see in this picture here, the bigger the sediment itself, the bigger the space, so it's going to have more rapid drainage or higher permeability. The smaller it is, the more impermeable it is, which means water cannot flow through it. So the closer it is, the harder it is water is to get through, so it's going to be really slow drainage. So we want to take a look at this checkpoint here. We want to figure out which is easier for water to travel. In order to figure this out, take your pencil and do this with me. We want to figure out if water was to hit this surface, how would it flow through this rock? Well, it's going to kind of weave through this like a maze, and this is how your water would flow through. Now in this instance, you can see that this is not moving very quickly down. But in B here, if we watch the water flow through here, this is very quick. You can even see that I'm able to draw these lines through here a lot faster. So when we talk about which is easier to travel through, obviously it's going to be B, and that means that it has a higher permeability. Water can move through a lot faster than it can in A. Porosity is a little different. We're not talking about water flowing through. We're talking about how much water can be in these pore spaces, or how much space is in between each of these grains. So if we look here, here's a low porosity, here's a high porosity. The blue represents the water within the pore spaces. You can see not much blue in this picture because there really isn't any space here, so it's a low porosity. Here we have a high porosity because we can see a lot of blue and there's a lot of different pore space. Now there's three things that affect the porosity of our ground. First is the shape of the sediments that we have. Rounder shapes are going to have a higher porosity because they have more space between the grains. What would be a really good thing for you to do right now is take your pencil and color in all this empty pore space in each of these, the round, the oval, and the flat. Once you get to the flat, there isn't any place to color because the flatter it is, the less pore space or the lowest porosity you can have. This would be like your clay size sediment, so we typically call that obviously a very low porosity, and it's pretty impermeable. Water's not going to be able to flow through there. So the rounder it is, the higher the porosity. The sorting really matters too. If you look at this sorted versus unsorted, again, take your pencil and color around these grains. The unsorted has these small sediments filling up the pore spaces. Over here, the sorted has lots of space in between. So if it's sorted, higher porosity, more space between our grains. Unsorted, you're going to have a lower porosity because there's less space between our grains. Your packing also matters. So if we have loose packed versus tightly packed, you can easily see, and you can color this in also, that this has way more pore space between our grains. This has a lot less pore space because it's so tightly packed. Now, one thing that does not affect porosity is the size, okay? Because we're talking about a percentage of open space. So if we had the small, medium, and large here, and they were all the same volume, this small has a lot of pore spaces, but they're small. This one has not as many pore spaces as the small, but these are bigger. So if we talk about a percentage, all of these would be exactly the same. And you can see that in this picture. These all have 48% pore space or porosity. Even though they're different sizes, they're still going to have the same amount of percentage of space. So let me show you an animation. So in this picture, we can see that we had small, medium, large, and unsorted. And when we release the water there, we could see that the small, medium, and large, they all had the same amount of water come out because they had the same amount of pore space or the same porosity. Same volume of sediment, it's just they're all different sizes. And remember, size does not affect porosity. Here, we have an unsorted mixture, and that is producing a lower porosity because what we talked about before, all these sortings and packing and shape, that's all going to affect our porosity. So which one here has a higher porosity? That would be answer choice A. And you can color in the empty pore spaces here, and you should be able to see that this definitely has more empty pore space than B. So as this checkpoint, we want you to go through each of these. We want you to write high or low. You could just write H and L, which has a high porosity, low porosity, high permeability, low permeability. Pause the video to do that. And these are your answers. There's no pore space here, so it's a low porosity. And water, if there's no pore space, water can't flow through, so low permeability. Here we can see some pore space if you colored that in, so it's a higher porosity. But if we were to flow water down on this, that'd be a serious maze that would have to go through, so very low permeability. Here, lots of pore space to color in, and if I tried to draw through the maze here, I would be able to do that very well, so high for both. And here, we're going to have low for both because I can't really color any space in, and without space, how can water flow through? So low porosity, low permeability. Last thing is capillary action or capillarity. This is the upward movement of soil. Big thing you have to remember is that this works best with small particles. So if we look at these tubes here, this is the largest tube, medium tube, and small tube. Water is going to rise highest in the smaller tube, and this has to deal with tree roots on plants. They can reach down to the water table and pull water up to the tree. Obviously that defies gravity, but that's why we're talking about it. These small tubes, the small spaces, are going to do that the best. And last is groundwater problems, pollution of aquifers or the underground reserves of water, sewage seeping into the ground, or even saltwater invasion. This doesn't happen here in Owego because we're not near saltwater, but sometimes if you're near saltwater, it's more dense. It can go underneath and get into your well, which obviously is a problem.